Hello everyone, this is your boy KP. Today we're just going to be doing a quick link list. It's a chain list. I'll be inserting a new node at the end of the link list. Okay, let's get started. I have the basic structure of the code in here, of the source code. And I'll just explain it quickly, but at this stage of the game, you should just be able to look at this and know what's going on. Now, I'll be I'll be filling in only the methods. The method, one of them will be just to insert the new node, or I call it here add node, and one of them would be just to print the list. As we see here, print list. I'll be focusing on those methods because that's really where the bulk of the work is happening. Alright, now I'll just go through this. I have your standard header files here to do structure and malloc calls, memory assignment calls, and this is the structure here. I'm assuming that you know what a structure is and how it works. In a linked list, you have to have a pointer that is a member in the linked list. That pointer is going to hold the memory location of the next node in line, the next node down the line. All right, linked list always starts with a head node, and then the second node, third node, fourth node, fifth node, sixth node. We're not going to be sorting nodes in this program. We're just going to be doing a simple chain method, putting one node after the next, after the next, after the next, despite of the order of the data or whatever. We're not sorting anything. Okay, I have here the header node. I assigned it null. There's nothing in it. And I have here last node. Last node is going to become apparent. Why that's important? Because you need somewhere, you cannot change the head node. Once the head node is set, you cannot change that. You need that to traverse the list when you're ready to do your searching or to print the list. You need the head node. So you don't want to change that in this type of linked list, which is to insert at the end of the chain. And then I have my methods here. I have them prototyped here. The add node is going to take the data. That data is going to be used to fill in the structure. And I have here the print list. That's just to print the linked list. Alright. In my main, where I'm going to be calling the functions, in my main I just have here some int values that's going to control the loop, the for loop, which I'll explain why, and the data. I'll be asking the user for the data, the information that's going to be put into the linked list. That's what linked lists are for. They're for holding information of all types. This is just a simple linked list, so we just have one type in there. That's important for us, and it's just going to be called data. It's going to be, I'm just going to use a number or something like that. Alright, and here is where we are going to be asking the user. Here I've determined that the size of this list is going to be 4, up to 4. Alright, so it's going to be 4 nodes or 4 lists in this software is going to generate. Alright, here we're asking the user for the data information. So when the first node is created, this data is going to be placed into that first node. Then it's going to go again to create the second node. It'll ask the user for data for the second node, data for the third node, and so on and so forth until I is about I equals 4, then that would be the end of the program. So we'll only be able to generate about 4 nodes or 4 lists. Alright, here's where we'll be calling the add node function. and we'll be passing the data that the user provides to that function to be put into the node. Alright, and this here is where we're going to just print the list. You have to traverse the list one by one and print them out as you go. Okay, so I'll be focusing mainly today on these. I'll define the methods here. Now on the add node, first what you want to do is you want to define a pointer. Of type struct node, because that's the structure we developed up here, of type struct node. And this pointer I will call new. I'll call this pointer new node. We'll do the direct assignment one time. Malloc will make the memory allocation. SI size of the structure. Terminates statement. Then we have to cast it here. Structure node of structure node pointer. You have to cast it here because Malloc returns a null pointer, I believe. Alright, that's in there. Now once that pointer has been created, we will now fill in the data in the structure here. So we're just going to say new node data, that's from the structure data, that's how you access it, equals data, the data that we pass to the function, equals data, that's the data that we pass to the function, right? It's declared right here in data. Okay, once that's done, we want to set the next pointer in the node to null. Remember, the last pointer in the list is always going to contain null, and since we're inserting at the end of the list, it will be null. The value will be null in the pointer. Right, that's null, and we now want to go and do some testing. We'll make sure, since we have to, head has to just one time, head has to now, since this is the first time we're creating the list, head is null, head has nothing in it, and head needs to be updated. So we say if head equals to null. Remember, head is important. That's the memory location that we are going to always need to start with, so that we'll be able to traverse through the list. Alright, if head equals null, you want to set head to equals new node. Head equals new node. And also you just want to set last node. Let's set the last node. Remember that pointer we created above here? That's going to be important. That's coming in handy right now. Alright, so pay attention to this. We're going to just set that now needs to equal the new node. Or head. You can make it new node or you can make it head. But it needs to have the memory value of the node. Alright, it always needs to have the memory value of the node, of the current node It needs to, that's important. All right, we have that created, and then we say, well, if else, if head has already been created before, so it's no longer going to be equals null. So if head is not equal to null, it means we are adding nodes now. Okay, so we're just going to use this. So if head is not going to, it's not equal to null, we're now adding nodes. Okay, so now you have to update. If head is not equal to null, you make you update the pointer of the node. Remember, the node pointers is the name is next. All right, that's the variable name of the node pointer that stores the pointer location, the memory location of the nodes ahead of it, or the next node down the line. So last node will update the next, will now equals, will equal the new node, will now equal new node. So next in the previous, the next value, the next pointer of the following node has to now be put back into the previous node. It has to go back into the previous. That previous node was once the last node. That now needs to know that there's a node ahead of it. So you have to now update that next pointer. And that's what this line just did. And now last node has to now come, has to now point to, has to now have the information of the newly created node. It has to save that information of the newly created node for the next time around. Alright, let's go for this again. Alright, this happens on the first time around. The very first node that's created, that's when this comes into play. Alright, head is updated and will now, from this point on, never change. Head is updated with the new node, or the very first node that was created, and the last node is also updated with the new node, the address of the new node, the very first node. Alright, no, we go around again. The loop goes around, asks for the more information to create the next node. This is going to get skipped, and we'll jump to this else if statement. Here, head is no longer null. That is true. So the last node pointer is going to be used to update the next pointer of the last node. The last node that was in the list. That's going to be used to update that pointer variable in that node. So you access, so use the last node pointer to access the next of that last node, and you update it with the new node. That's how the last node knows that there's now a new node. It has to be updated, and then the last node pointer is now updated with the new node. It now gets the address of the new node, newly created node. Okay, that's done. Let's go down to the print statement now. Okay, here we create a temporary node pointer because we don't want to mess with the head. Okay, but we need to know what the head is. The head node. The head memory value. We don't want to mess with that. Alright, we're going to just make this now head. We make that head, and we'll start at the, so temp now has head. So now this is pointing to the beginning of the list, the first memory location, the first node in the list. That's what it's pointing to. So as long as temp is not equal to null, traverse the list. That's what that statement is saying. As long as temp is not equal to null, because the last node pointer will have a pointer value of null. The last node pointer variable will have a value of null. Always. That's how linked list works. That's how you know you're at the end of the list. Alright, so this would become, let's print f %d temp, our arrow operator, and the data, because we're printing out the data. Okay, we'll put a tab here because we're going to have a nice space in between there. And here we want to update temp to now point to the next pointer, the node of the next, the pointer variable in the next node, the pointer variable next in the next node, in the following node. That's how we traverse the list. I hope I'm getting that. Hope you understand what I'm saying. Next, yeah. So it's going to go around again. It's going to go through every node until it comes upon this null. This null, it will always be placed in the pointer variable of the last node. The pointer variables of the nodes, we call them next. Here it is up here. We call them next in the struct. That's the pointer variable of the node. It has to be a member of the structure. Alright. And here we just put a char just to give us a clean exit. Okay, so that's about the size of it. Let's just run this and see what it does. Run it and see what it does. Okay. Compile. An error! Well, what do you know? Struct. What happens? stru struct. Alright. Good. So let's now execute this. Enter data to store. Let's enter 5. Enter data to store. We're in that for loop, taking data, creating, and that's creating the list and the nodes. Enter data 8 200, and there it is. There is your list. The print statement print out your list in the as it was entered. All right, your first, second, third, and your fourth. So we successfully entered our nodes at the end of the list. Thank you very much. This is the end of the list. Thank you. Have a good day. Thank you for watching. Bye bye.